Okay, so if you remember back to Monday in this activity that we did about noticing the more frequently that you compound money, once a year, twice a year, 4 times a year, 12, 26, 52, and so on, all the way up to 31 million times, we noticed that the balance and the interest went up every time. But what we started to notice was it went up a little bit, then some more, but then it started going up by tinier and tinier and tinier amounts until it almost didn't go up at all. And we graphed it, and it looked like this. Here's the chart that we made. So you would think that the more frequently you compound and calculate interest, that this would just keep going up and growing and growing and growing. But it reaches what we called a limit, and it kind of leveled off. So it doesn't matter if we do it every second, every millisecond, 100 times per second, every nanosecond, it's going to level off at this 2744. So instead of doing it and calculating it as fast as you possibly can, there's a math application for that called continuous compounding. So keep this file open that we had from earlier in the week, because we're going to add a third tab in a little bit. We're going to come back to this and add a continuous compounding interest tab. But for now, we're going to go over to the notes. So again, you could write these out and upload a picture of them, or use this file and type along with me and then upload the file. Either way. So, continuous compounding interest notes. Continuous compounding. So we've had simple, we've had compound, and now we have this continuous compounding. So the objective is just to discover the limit of continuous compounding. And in some ways we did that on Monday. We discovered that limit. So what is continuous compounding? Or what is continuous interest? It's basically when interest is instantly, all right, not weekly, not monthly, not every second, but this concept of instantly added to the principal and then instantly recalculated. So it's almost like it's being compounded so frequently, it's just happening continuously, instantly. Not even this concept of every second and doing over again every second, just happening all the time. It reaches this limit where it's happening so fast, it's like infinitely fast. So the compound interest formula. This is how it looks like in regular algebra. The amount equals the principal times e raised to the RT, the rate time. So it's this new thing, e here. We'll get to that in a minute. The a is the amount. P is the principal, which is the amount you're investing. By now we know R is the rate as a decimal, like 2% would be 0.02. And T is time in years. So this new thing over here, E is it's approximately 2.71828, and then it goes on and on and on. It's almost like pi in a sense, where 3.1415926, it goes on forever and ever and ever. It's an irrational number. So let's double click inside this little box here. And we'll add it right to this. So E is an irrational constant, sort of like pi, like 3.14. This is like the other one that you'd learn a lot about in math, is E. And it's, like I said, it's always equal to 2.71828, and then that goes on, just like pi goes on forever, this goes on forever too. It's actually a button on your calculator. You could look on like a TI-84 or any other calculator and you'll see this E. And it's the exponential is what it stands for, and it always will equal 2.71828. But in math, you usually raise it to something, to a power, so it'll usually be like an E to the something button. But nevertheless, it's 2.71828, blah, blah, blah. So this is how it looks in algebra, but this is how it's going to look in Google Sheets. It's a little bit wacky because Google Sheets is more of a computer than a calculator. So the amount equals P and then times, you have to put the time sign in, and then you type in EXP. For some reason, it's like an anti-abbreviation. Instead of just the letter E, it makes you write out EXP because it stands for the exponential. And then, because you're using this exponential function in Google Sheets, you don't have to raise it to the RT. It automatically raises it to the R times T. So this is how we're going to write it out in Google Sheets. P times EXP parenthesis R times T. But it really just means this, PE to the RT. Okay, so you might remember these numbers. Bill deposits $23.50 at an interest rate of 3.1% compounded continuously. What is his ending balance after 5 years? Remember this? $23.50, 3.1% for 5 years. And we did it at all these different frequencies. So I wanted to continue with that same number. So the principal is $23.50. The rate is 3.1%, which is 0.031, and the time is 5 years. So in regular algebra, this would look like this. A equals P E, and you would raise that to the R times T. And that would be how you type it into a calculator. But on Google Sheets, we're going to go 2350 times EXP parenthesis 0.031 times 5. So this is how it looks like, or how it will look like in Google Sheets. When you type this into a calculator, just types it into a regular calculator and it says 2743.99620. But if you notice, 996 is going to round off to 2744. And if we look back, that seems to be what happened when we reached our limit after hour, minute, second. It was just 2744. So now using this E, that seems to be the high limit that you can get to. You never get any higher because you reached this limit. Alright, let's just take a look at example 2, same idea. You deposit $6,500, so that's your principal, into a Capcom account. The account has a 4.12% interest rate, which is 0.0412. Decimal point gets moved over 2 places, as we know. How much is in the account after 3 years? Well, in regular algebra, it would look like the amount equals principal times E raised to the R T. But in Google Sheets, it's going to look like P times EXP parenthesis 0.0412 times 3. That's what it will look like when we type it into the spreadsheet, and that's how we do things in this class, so we'll talk about the spreadsheet more. If I type that in to a regular calculator, which I just did over here on the side, I get 7355.16. And we'll check that with Google Sheets in a little bit. All right, it's been a little bit, so now we'll do it. Now it's time to recreate these two problems in Google Sheets. We're going to set up the two example calculators like we did for simple and compound to verify that they're working correctly and we get these two numbers, 2744 and the 735516. And then if we get the same answers with our calculator on our spreadsheet, we're ready to go, and then we'll do these three problems here. So go back over to your Google Sheet that we've been using for the past few lessons with simple and compound. And we'll make, just like we had a simple interest tab and a compound interest tab, I'm going to add a third tab by hitting the plus sign over here. I'm going to click in here and type in continuous interest. And then I'll title that up at the top here. But I'm going to make it much bigger for a title up here. I'm going to merge. I'm going to make the font bigger. Change the color. And we'll put example 1 here. So go ahead and type this little table in to rows 4 through 8, continuously compounded with principal, rate, time, final amount, and then make your borders. Pause the video until you're done. Okay, so now let's type in the formula in cell B8, where the cursor is blinking there. We always start off with an equal sign, and it was P, which is going to be in this cell, so B5, times EXP, and it understands that command. You can even see it down here. It's called Euler's number, approximately 2.718. So it knows that command. And then we're going to go parenthesis rate, which is B6, times time, which is B7. That's all there is to that formula. Equals B5 times EXP, parenthesis B6 times B7. And it won't say divide by zero error because we didn't divide by anything. It'll just say 0 right now. Go up to the top and make sure your format is currency, so it comes out as money. And I'm just going to make a second copy of this over here because we had two examples, so I don't have to type it all over again. And notice it brought the formula with it. It's always important to make your formula before you copy your calculator, so then the calculator gets copied and saves you all that work. So let's just double check our calculator here. This example 1 from our notes. Bill had 2350 at 0.031 for 5 years. Bill had 2350 at 0.031 for 5 years. That's money too, so I'm going to make that money. And look at that, 2744. Just what we expected, because when I typed into the calculator, the regular calculator, that's what we got. So our calculator looks like it's working. Let's just double check with this one. Capcom, $6,500 at 0.0412 for 3. And after you type in that information, you get 7355.16, which is what we had on the regular calculator. So we know they're working. So it's always good to check your calculators. Okay, so we'll make a title bar here and we'll call it questions. I'm going to merge that together. I'll center it in the middle. And now I'm going to copy this 3 times. 1, 2, 3. And I'll just delete the info, but don't delete that bottom purple cell because that has the formula in it. Go ahead and type this at the bottom here for the third one. Will she have enough to buy the car? Because I'm referring to these 3 questions here on your notes. So go back to your notes and do number 1, number 2, and number 3. And then submit this file for your continuous notes.